Okay, this is our group project on the Real Salt Lake Data Warehouse. Members of our group are Caitlin Matheny, Justin Sosi, Naresh Kari, and me, Jacob Whitaker. So, general description of what the Real Salt Lake are. They're a professional soccer team. They play for the Real Salt Lake in Sandy, Utah, and are actually one of the best teams in the league. They won the MLS Cup, which is like the championship trophy in 2009, and were the runners-up in 2013. So the goal of the Real as a company and as a sports team is to maximize revenue by having the best team possible and being able to attract the best players, and to fill up the stands and make the most money. Okay, so we as data warehousing consultants have been hired by the Real to produce a data warehouse that will be able to easily aggregate and display information that will aid the team in producing wins and further increasing the value of the team. So some of the business requirements that we have come up with are like a general game stat summary report, and this report will include like how many goals were scored by the Real, what player scored those goals, what minute in the game were they scored, how many goals did we allow, how many shots were taken by both teams, how many shots were blocked, and how many fouls were called on each team. And then in addition to this general game summary report, we'd like to have some more specific details that aren't quite as easy to find from the data that we have. So some of these detailed requirements would be: which player was in control of the ball for the longest time, where were the players positioned in the field when they took shots, how far apart were players when they passed the ball, what areas of the field did most of the passes occur, and was there a particular spot in the field where fouls occurred more frequently. These detailed requirements will allow the team to make small adjustments in both offense and defensive strategy to increase player efficiency and effectiveness. Once the above requirements were finalized, we started analyzing the data to get a sense of what the actual facts are, which leads us to our dimensional model. Okay, our logical dimensional model. Basically, we had to determine beforehand what facts we wanted, the dimensions that would feed into the fact tables, and then the level of granularity of the data, which is pretty important in data warehousing, so you can have consistent granularity across the whole data warehouse and be able to aggregate it in a logical manner later on. So based on the source data, we determined that the events like goals, shots, and passes, and the player's position are the facts. We easily came up with various other fact dimensions like goals, shots, penalties. However, we just decided to go with just those first few. We hope to, in later iterations, we would hope to determine other facts and create other fact tables based on the data we have that would be useful. So we have a bunch of tables, and I'll go through those individually. First, our team table. This contains information about a particular team, such as team name. We have the team ID and team name as the main attributes. However, we would extend this dimension to have more fields later on, like who the team captain is, who the coach is, the owner, etc., to make it more generalized and have more information. Then we have our player table. So you can see that's related to the team because the team has players. But we have the player table is actually unique because it's a slowly changing dimension table, which means basically it's because players at one point in time are on a team, but they can be traded or whatever, go to different teams or free agency or whatever. So that would change slowly over time, and that would be something that would have to be updated, but it doesn't change, every second of every game or anything like that. So the data, this dimension contains information such as player name, current team association, and importantly, the start date for that association. So we could have historical data of what players were on what teams at what date, historical date. And then it also has a player's role or position, like goalie, forward, midfield, etc. Then we have our position table. This dimension contains information about the exact location of a player on the field. So there's an XY coordinate, and the XY coordinates are relative position to the sideline of the bench sideline and the midfield line. So at that point, the X and Y's refer to the position of the player on the field. We also have our game date. This is a date dimension describing the date of the game, including information like what quarter of the year it's in, the month it's in, the day of the week that the game takes place. And then we have our time dimension. So this dimension describes the time of the game at which an event is occurring. So what minute did a goal happen? What minute did player A pass it to player B? Stuff like that. Then we have our event dimension, and this just describes all those things I just talked about: the goals, touches, passes, etc., things like that. So then we have our two fact tables. We have our game stats and our event stats. And these are pretty self-explanatory by the title. However, they're both factless fact tables based on which a user can mine data about events in a game, positions of a player on the field during games, and even the timestamp of events and player position. So basically they just contain the different keys from the dimension tables, and you can just mine whatever corresponding data you need to for that. Okay, so before we go on, I want to talk a little bit about exactly what this data is that we're using in our warehouse. So the MLS and I think the Real Salt Lake and all of the MLS, I think, uses what's called sports view data. So basically what there is there's a set of cameras on the field that can capture the player number, and there's another camera that records the ball location. So the data is tracking real time automatically what's happening, who's happening, or who is doing it, and where on the field these things are happening. So our particular data, we had two data sets. The first is event data that shows each event in a game and the time during the game at which that event occurred. The second data set is every player location or position on the field at all times of the game. So I talked earlier about the coordinates from the midfield and the bench sideline. That's 0-0, and everything else, all the coordinates relate to that position. So once the logical data model was set up as our baseline, we started implementing the model to create an end-to-end ETL process, and also the physical dimensional model. So I'll talk a little bit about the technologies we use also. We just hosted a server on Amazon Web Services. In the R2 instance, we use MySQL Workbench, MySQL Database, Pentaho Spoon, or Kettle Transformation Integrator, the Pentaho Schema Workbench, the Pentaho BI Server, and the Pentaho Report Designer. Okay, so on to the ETL process and how we actually integrated the data that we had into our warehouse. So first we started the ETL process by we had two tab-separated CSV files provided by Professor Boyle. And instead of chopping this data up into different CSV files and loading those individually, we went it seemed easier to start with, but it ended up being a lot more difficult. We just loaded the two different CSV files into two different staging tables, like a staging area, and they were called stage 1 and stage 2, and from there we ended up separating them out into the different dimensions. Okay, so from the staging area, the next transformation we made was to take the team data and load those into the team dimension. So we extracted the distinct team data from both of the source data sets and loaded them into the team dimension. And this shows exactly how that query happened. This information, since which player is associated, we use the database lookup in order to find the player's team. Then we assigned a null as constant field to find whether the player is still active with the team. If it's null, that indicates that the player is active. If a player is not active, then we show that with an N, a capital N. Okay, so in the interest of time, I'm going to skip a couple slides. They're kind of not that exciting dimensions. We have a date dimension, which is pretty straightforward and standard for almost every data warehouse. But I wanted to talk about this loading the time data into the time dimension. So basically, with the time, we decided to break down the granularity into minutes, hours, seconds, and even milliseconds. The reason for going down into milliseconds is because there could be two events happening at the exact same second, or two players could be involved in an event at the same second. So we decided to go just with the millisecond, which provides a lot of data, by the way. Lots of lines. The data is straightforward. So on to our fact table. So as I talked about earlier, both of our fact tables are fact list fact tables. So this particular one was our game stats fact table. And basically all a fact list fact table does is holds the warehouse keys of the various dimensions that are related to it. Doing this and joining against the individual dimensions, we can pull any type of information we want, any kind of data. So this particular table, the foreign keys are game date, player ID, time ID, position ID. Okay, so this is our second fact table, the event stats fact table, and it's basically the same thing as the first one, a fact list fact table. This is the screenshot of our OLAP cube that was created from our schema. Pretty straightforward, just allows us to slice and dice the data any way we want to. So pretty much the main scope of our project was to get the data transformed and loaded into the data warehouse. We did put together one sample report. It's not too fancy. We don't have any fancy graphics or anything, but just to give an example of what you can pull from the warehouse that we created, is this sample report. This actually report was quite long, but this is just a screenshot of the first page. So basically, we use Pentalo Report Designer for this. It shows each event by player, what time during the game the event happened, and what date the game was on. So basically, it's pretty broad. It pretty much just summarizes every event that happened and who did it and what time of the game it was in. You could search through this and find other aggregated things, but in an ideal world, we'd spend a lot more time and effort creating reports that would show aggregated data, like how many points were scored or how many goals were scored in a game. Basically, all of our requirements at the beginning. So, how many points were scored in a game? Who scored those goals? What minute of the game those were in? How many goals were scored on us? How many shots were taken? How many shots were blocked? And also on the more sophisticated side, we would have reports that showed things like where on the field most of the penalties were called, where on the field most shots were taken from, and those kinds of things. So that basically wraps up. Again, the scope was kind of just more focusing on the ETL side of a data warehouse and getting the data integrated without having to do a bunch of different CSV files, but being able to import the data from a staging area into particular dimensions without having to separate those in the source files in the first place.